Anton from Bulgaria, and welcome to yet another video from our JUnit tutorial. It's raining a lot of here, but I believe that we'll manage and we'll have yet another video. Don't forget to subscribe to the channel. There are many awesome videos during the week. Hit the ring bell. Also, keep in mind that in the description below, you will find lots of reference articles and a link to the GitHub repo. So without further ado, let me share my screen. Last time in the previous video, we were talking about data-driven tests. I showed you many ways how you can run tests with many parameters, and JUnit 5 is really rich of such features. And today we are going to upgrade our solution and run our tests in parallel. And the next time, keep watching and subscribe to the channel to see a really awesome video how we are going to run our tests in the cloud in parallel. So let's get started. I'll just quickly remind you what we did before. I wrote a test of this awesome open source website to do MVC, where we have the same functionality of to-do list implemented with different web technologies such as Angular, React, and many others. And I showed you basically how you can write a really stable test with Selenium. Basically, the test is just adding different options here, pressing enter, we're checking some, and we're checking this, how many items left. This is our test. Let me show you the code again, and we're going to upgrade the solution to run the test in parallel. So this was our code before. Basically, I used in the first version the value source JUnit 5 annotation, where we listed all of more than 20 technologies, where as a parameter here, and for each technology we have a separate test run. And we have a special method open technology app to open the particular application, the next page. We are adding 3 items, then we are checking the checkbox, and we are inserting what left. And now, if I want to run this test in parallel, in order to do so, sometimes we need to run the same tests in different browsers, right? And I wanted to show you a simplified way at the beginning, and then we'll upgrade it. So I created basically, I copied the test with all of these helper methods at the bottom, where we are waiting for the element to appear, then we are checking everything, we are formatting and validating the text and all of that. So I copy-pasted the code and created these 4 files here, compile time JS.To. Basically, I just wanted to have separate tests for compile time JavaScript libraries. They're just this of them. And I again made a data-driven tests. Below, basically, we needed to copy-paste all of the helper methods. And the difference here is that in one of the files, I have here initialize the Chrome driver before each test. And also, I'm downloading the Chrome driver before the execution of all of the tests in this class. Then we have basically copy-pasted the same class here, but instead of Chrome, we're downloading the Firefox driver, and before each test, we're initializing the Firefox driver. And the technologies and all of the methods here are copy-pasted. Don't worry, in minutes, we are going to upgrade this solution and make it much better and more maintainable. Then basically, the whole code is almost the same, with the difference here that we have different technologies. I wanted to, as I said, have pure JavaScript libraries, Backbone, Angular, JS, React, all of that. And again, in one of the files, we're downloading the Chrome driver, and in the other Firefox driver, we're downloading it and then initializing it. And now the simplest way to run the tests in parallel is to use JUnit platform properties. And I already added these three properties here, settings. First, we needed to enable the parallel execution. Then we are saying, please, by default, run the tests in a particular class on the same thread in one process. However, we are going to run in parallel all the different classes. However, there will be a problem with WebDriver, most probably. And before running all of this, we are going to basically, we need to reuse some of the code instead of, every time downloading the driver, initializing the browser and all of that, and also make it thread safe, meaning that instead of occurring weird problems with parallel execution. In order to do so, I'm going to create a special class that I'm going to name driver adapter. You can think of the driver adapter as a special wrapper that we are going to use to initialize the driver. We're going to move all the different helper methods like validate inner text, find element, get actions, and all of that. But we are going to make it thread safe. This is the important stuff. Also, I'm going to teach you during the process of two design patterns. One of them is called factory method, and the another is called template method. The first thing that we will need is to create enumeration called browser. And in the browser enumeration, we are going to use it in order to provide which browser we want to start. And then in the driver adapter, we are going to use it. Now, first thing, I'm going to use a constant for the wait for timeout here, private final int wait for element timeout, 30 seconds. Then in the first thing that we can do is to have a private variable to WebDriver like this. However, in order to make it thread safe, there is a special class in Java called Threadlocal. This Threadlocal means that we will have this special class. It's something like a container for different objects. And through it will preserve the instance for particular object just for the right thread, the right process, right? And this is how we're going to make our code thread safe. We'll have the same Threadlocal for WebDriver wait, the class that we use for waiting for elements to appear. And we'll have the same for actions. Actions is the class for making a little bit more complex actions like typing on the keyboard, drag and drop, and others. Next, here we'll need to create the so-called factory method. I'm going to name it start. Basically, the start method will be responsible for initializing the driver and starting the proper browser, and again, make it thread safe. Public void start. And here we're going to use the new enumeration browser. And then here we need to initialize all the thread local instances, driver, or let's call it WebDriver, it's fine. WebDriver. And then we'll have a switch statement where we're going to initialize all of them like this. Based on the browser type from the enumeration, we're downloading the proper Chrome driver, and then we're basically adding to the thread safe container the new instance of Chrome. And that's it. At the end, we need to initialize the WebDriver weight and the actions with this thread safe instance. Here it is again. There is a special class set. Basically, we are adding the instance of this object to the thread safe container. Again, we will have the quit method. You can think of the adapter. As I said, it's a pattern where basically you're adding new behavior, you're changing the names of the methods, and basically changing their public API. By API here, I'm not referring to web APIs, but API when you're designing libraries is about how you name your methods, how many parameters they are, how usable they are, and all of that. And also, here I moved all of the methods that we'll further need. Instead of copy pasting them between the different files, we have the quit methods. And as you can see now, if we want to get outside of the parallel testing container, thread safe container, we use the get method, and then we're calling quit. Everywhere inside these methods, we first call the get. And then I'm going to create a thread safe getter for the actions, like this. What else? Do we need something else? Probably not. Also, we're going to create a special base class for all of these tests here to reuse the before all, before each, and to provide a getter, thread safe getter to the adapter. So I'm going to create a new class called web test. I'm going to mark it as an abstract because, as I said, we're going to use another pattern. Here I will have the driver adapter. Then what else? We will have before each method, and here now, as you can see, we don't have now this initialize driver. This is the so-called template method that we need to override in each of the implementations of this class, where we are going to call the driver adapter and to call the start method and to mention which browser we want to start. This is why here we provide this get driver. If it hasn't been initialized, we're initializing it, and then we return it. And now let's see how we can use it in tests. Basically, in this Chrome driver, we can extend web test. And then, as you can see, we are forced to implement the template method. Of course, I'm going to bring it to the top so that it's more readable what we are doing. I'm going to, we no more need all of this. Also, we don't need all of this. Actually, we will need some of them, but let's see. Then, as I said, we'll need get driver start. This is how we start, right? And now we have, instead of wait and find, what else? We have the validate, find, and go to URL. Now, here, in order to use it, we need to use the get driver. Go to URL. And here we need to use find element. Now we don't need this validate. because we moved it to the driver adapter. Here we need to use the point element here as well. And we don't need anymore this one. And here we have get actions. This is how we refactored our tests really fast. We can do the same for the rest of the classes. However, as you can see, again, we still have many methods here that we are not reusing, right? We'll have a separate video dedicated to page objects. This is maybe the most popular design pattern in automated testing for the web. Now we'll create really simple implementations of it. If I need to tell you what it is, basically for every page, we have a separate class that it's named. For example, this will be our main page, and then we'll have this to-do page for each of the technologies. And here we are abstracting in this particular class, the to-do page, we'll have all of the different elements of the actions that we do, and sometimes we put the different assertions. That's it. And this is how we reuse this code. So I already prepared them, so I'm going to show you. We have the main page. I'm going to add it. And in the main page, we use the driver adapter. We have a constructor to initialize the driver adapter, of course. And I moved here the two methods that are related to the main page. We have open to open the home page, and then we have the open technology app. And then, as I said, we have the to-do app page where most of the logic is placed. Again, we have, maybe you can skip the open, it's completely fine. And then I moved all of the different methods that we had here below because they are related to this to-do page. So I moved them here so that we can reuse them like this. We have the assert left items, get item checkbox, open technology app, add new, to-do item. And the last piece that I wanted to reuse most of the code instead of, again, repeating everything. Actually, next time I'm going to show it. The first thing is that we need to initialize the two page objects. Actually, I'm going to show you. It's called a facade. Facade is basically a special class that contains a workflow combining two page objects or more. And here, what it is. Instead of repeating everywhere, main page open, technology, all of that we had in the test, in the facade, I added through composition the two page objects here, main page, to-do app page. I initialize them in the constructor, and then I have a single method called verify to-do list created successfully. Basically, this is our test, and we provide all of the data that we need, the technology, items to add, items to check, and expected items left. It's the same that we do in the test, right? I'm just creating the workflow here. And if I have to, use this inside here, instead of page objects, first I'm going to have a private field to the to-do facade. Then I'm going to initialize it like this. Since it requires the two main page objects, before each test, I'm creating the facade, new instance of it, and then I'm providing the main page that requires the driver adapter that I'm providing in its constructor, and the same for the to-do app. And afterwards, we no more need all of these methods here. And we need to, now instead of hard coding the data, I will have two lists, items to add, and we are using this factory method of to initialize the list of items to be added and items to be checked. And then we just need to call our facade or the wrapper or the workflow as you wish. So now here we call verify to-do list created successfully. We provide the technology data-driven for the value source and all of the rest. Basically, we will have the same for the Firefox. Of course, here we will have, we need here to extend web tests like this. Here we're starting Firefox, and we will do the same for pure.js. We're extending web test, we're starting Chrome. Here we have different data. The rest is the same. Of course, we can maybe further refactor the code to reuse further some of the code, but I won't do this. And as I said, now we are ready to run the test in parallel. So here we need to mention that the parallel testing is enabled. The default is that we're going to run all of the classes concurrently. You need to select all of the files that we want to run, right? And then click Run Compile. We're going to run the test from all of these 4 files. Build has been started, and we have a problem. Let's see, what is the problem? Let's try like this. Very simple. Yeah, the browser has been started. Everything is fine. By the way, you can further, here, as you can see, we have in parallel one Chrome and one Firefox. I'm going to stop them now. Also, you can, you have additional options if you want to set how many threads you want to start. Again, we need to enable the parallel execution. By default, we set concurrent, and we can say that we want a fixed parallel strategy. And if you set it to dynamic, then JUnit 5 is really smart to determine how many processor cores you have on your machine, and then determine how many threads it should start. But here, because I know how many cores I have on my machine, I set it to 8. This means that it will start simultaneously 8 different browsers. It's really awesome. It's really cool. It has many, many options compared to other frameworks. So I hope that this was useful to you. Check the Lambda test platform. Next time, in the next video, I'm going to show you, instead of running these browsers here, because this is not really useful, we're going to check this awesome platform and what it can give you. So we are going to talk about cross-browser testing in the next video together with JUnit. Thank you for watching. If you have comments, please put them in the comments below. Or, of course, when you download the code in GitHub, it's free and open source. You can raise an issue there, and I will gladly help you. Check the blog of Lambda test. There are many awesome JUnit videos and tutorials. And also, don't forget to get your certification about JUnit and Selenium. Thank you for watching, and see you soon.